Hello everyone. Today we are solving the question on asteroid collision. So this is basically the question for stack. So here's the problem statement. We are given an array asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents the size and the sign represents its direction. So if it is positive, that means it's going right, and if it is negative, that means it's going left. Each asteroid should move at the same speed. Find out the state of asteroids after all collisions. Now, if two asteroids will meet, the smaller one will explode. And if both are the same size, both will explode. Two asteroids moving in the same direction will never meet. Okay, so let's understand, first of all, what this problem is. So, for example, let's just understand it by example only. So let's say we have an input array 5, 10, and -5. So if 5 and 10, 5 and 10 are both positive, that means they're going in the same direction. So if two things are going in the same direction, there is no chance that they can collide. So no collision is occurring here. Now we have 10 and -5. 10 and -5. So 10 is going in this direction, and for my 5 will be going in this direction because it is negative. So they both can collide. But who has the larger magnitude? 10 has the larger magnitude, so 10 is going to stay and 5 is going to explode. Let's see the other example, 8 and -8. They both are of the same size. They are moving in opposite direction, and if they will collide, they're gonna explode. Okay, so let's understand this problem better by going into this whiteboard and see how we can solve this problem. So let me just copy this and put array first of all here. And yeah, let's go to the whiteboard. So this is our array. Let me change this to black. So this is our input array. So let's see, let's just take some of the constraints that we have to keep in our mind. So here we have 5, here we have 10, and here we have -5. Okay. So if it is 5, that means it is going in the right direction. It will go here. Okay. Now, if it is 10, again, it will go in this direction because they are of the both same size. Now, the third element is -5. Now, third element is -5. That means it will go in the left direction. So if we'll have a look on the first two element, they can't collide because they are moving in the same direction with the same speed. So they can't collide. Now, 10 is moving in this direction and 5 is moving in this direction. So they're gonna have to collide, and in this way, 5 will get explode. Why? Because 5 has the smaller magnitude as compared to 10, right? So 5 will be destroyed, and the final answer will be 5, 10. 5, 10. So here is what the problem statement is, and let's see how we can approach solving this problem. We can totally use stack to make sure we are removing and inserting the correct elements. Okay, so let's take a stack here. Okay, so we have a stack. We have a stack here. Now, this is our array. Our array is 5, 10, and -5. Okay, so let's just insert the first element into a stack first. So this will go here, 5. Now we will have to insert the elements into the stack one by one. So what are some of the things that we need to make sure that we are following that? So first of all, we need to make sure that whatever the top element is, whatever the top element in the stack. So currently top element is 5. So whatever the top element is, it should be greater than 0. This is the first and foremost requirement, right? Now, what is the second requirement? Second requirement is that the current element. So for example, 5 is already inserted. So now our iterator, so let's say we are iterating it with A. So 5 is gone. So now iterator will be on 10, right? Iterator will be on 10. So iterator will be on 10. Now we are on 10 now. So current element is 10. So one more thing we'll have to make sure that if we want to, mm, if we want to have the collision, the current element needs to be negative. So currently it's not negative, it's 10. So if it is 10, we are going to straight away put it into the stack. So we will just put it here in the stack, and this will just have the value equal to 10. Now our iterator will move one step forward and it will come to this place, right? Now iterator is here at A. So now it is negative. So here comes the fun part. Here comes the fun part. So here it is -5. -5, that means collision is going to occur at third element. Collision is occurring. Okay, I'm gonna take the both cases where the magnitude is greater or magnitude is smaller. So in this scenario, basically we have the magnitude smaller than 10. So collision is occurring at 10 and -5. 10 and -5 is occurring. So if we find out that if A is less than 0, if A is less than 0, we are just making it A is equal to 0. That means we're just breaking the loop that we have. What will be the condition of loop? The condition of the loop is basically the same thing. So first of all, the stack should not be empty, right? Stack should not be empty. And then st.top should always be greater than 0. And st.top should always be greater than 0. And the current element should be less than 0, right? Current element should be less than 0. This is the condition of our while loop, right? Uh, yeah. So this is the condition of our while loop. So yes, so if we'll find that this is negative element, then we can just make A is equals to 0. In this way, this while loop is going to break. Now, when the while loop will break, it is just going to discard this element, and then finally we'll get this answer 5 and 10. Now, how can we find out that if this is greater magnitude or not? We can just find the sum. So let's erase this scenario. Let's erase this example, and let's put -15. So in -15, collision is going to occur for sure. But in this case, 10 is less than 15, right? So they both are moving in same direction. At this time, 10 is going to explode because 15 is bigger than 10. As 15 is bigger than 10, we can have some sort of sum which can keep track of which one is the bigger magnitude and which one is the smaller magnitude. So let's say we are keeping the sum here. So if A sum st.top. If so now if we'll do this sum 10 minus 15, we are going to have -5 as the sum. -5 as the sum. So this will find out that 10 is the element that is going to explode. So we will just pop the element from the stack. Pop the element from a stack if the sum is greater than 0. Okay, if the sum is greater than 0, sorry, if the sum is less than 0, sum is less than 0, we are going to pop the latest element from the stack, and we're going to push the element that is there on the other side. If sum is greater than 0, that means the same way we had in that previous case where we had 5. So 10 minus 5 is 5, +5. So that means it was greater than 0. That means we are going to explode the -5, but not the 10. So in this way, we just need to discard the element that we have in our current iterator. So we will just do this. A is equals to 0. So one more thing I mean, lots of people would know that, but this follows the LeetCode. That means first and first, last and first up. So the whatever the recent element is, pop operation is going to remove the recent element that was added into the stack. So this was basically the approach of how we can solve this problem. And now let's go into the source code and then see how we can code this. I think once we code it, we can have the better understanding of whatever is going on in this problem. So there we go. So first of all, we need stack in our code. So stack, we can just initialize our stack, something like this. Now we need an iterator. That means we just need to iterate our element into the asteroids array to make sure we're going through each and every element into the array. Okay, now we need to define a case where collision is happening. I mean, top element should be positive, and the current element at A should always be negative. Should be negative. So this case is for collision case. Okay, so let's define a while loop here. First of all, while loop st st dot empty. Then st dot top is should always be greater than 0, and A should be less than 0. Okay, so this is the case. Now we need to define the sum that we just discussed here in this case, the sum, to keep track of which value is bigger and which value we have to keep, which value we have to exclude. So let's define this. In sum is equals to uh, st dot top. So A plus st dot top. This is going to be the sum. Now let's explore the scenarios that we can get. So first scenario we can get is if sum is greater than 0. If sum is greater than 0, that means the current iterator element is obviously less than 0. It's negative. Okay, let me just come. Okay. If sum is greater than 0, that means 5, 10, and minus 5. See, in this case, 10 and minus 5, the sum of 10 minus 5 is going to be positive. That means we are going to explode the minus 5 and then we are going to keep the 10. So this is the case that this is a scenario of this example. So we are just going to keep A is equals to 0, because if we'll keep A is equals to 0, it's going to discard the current element suddenly, because the condition of our while loop is A should be less than 0, and then if we will keep A is equals to 0, it's going to break the loop and it will just discard the element that we have. Now, second case, if sum is less than 0. If sum is less than 0, so let's keep it here, 5, 10, minus 15. So this is the case for this particular, this is the scenario for this test case. Okay, I think I'm messed up with indentation. Yeah. So if sum is less than 0, so what are we gonna do? So in this case, we need to pop the 10 and we need to keep minus 15 here. So we can do this st dot pop, because we are removing the element. St dot pop. Okay. Now, what is the other condition? Other condition is else both of same size. a different direction. So both should be of the same size but different direction. If this is the case, we are just going to pop whatever we have in our stack, and we're also going to discard the current element because we are returning the empty, we're returning the empty array because everything is exploded now. Okay, perfect. And now, so this is the case for our stack. So this is, and if a is less than 0, and simply push the element of the stack. So yeah, if the current element is greater than 0, then we don't need to worry about anything, and we are not going to check anything. We can just push the element into the stack. So if we stack dot push a. Now int, we have this okay. For while loop, so now what's the second thing we need to do? We have our stack now. So now we need to put all the elements of our stack into an array because this function is returning a vector int array. So let's define the size first. So let's keep size as equals to st dot size. Okay. And then let's define a vector of size s, vector the same size basically. So vector in, let's name it result and give it a size. Now, as stack follows LeetCode, if we will just insert all the elements from the stack one by one in the conventional order, it is going to return the reversed string because it is following a LeetCode. So what we need to do is we need to start from the very end so that it keeps on removing one element, removing the elements one by one, and it will put all the elements into the vector array, right? So we can keep our I is equal to st minus 1, sorry, size minus 1. So it will start from the very end and it will iterate through each element one by one in the reverse order. In this way, we will have the correct string in an output. So this is just the basic operation to copy all the elements. So result of I is equal to st dot top, and then we will remove the elements one by one, and then we will do I minus this. And then at the very end, we will just return the resultant vector. So I think this is our solution. Let's see if this works. Okay, it is accepting all their test cases. Let's try to submit it. And okay, perfect. Yeah, so the solution is working fine. So that, yeah, that was everything for this particular problem. And thank you so much for watching.